Hello, we're going to cover a topic. I've covered this before, but it seems like it deserves to be covered again. It's the Order of Operations Convention. All right, so the Order of Operations Convention, it's a mathematical convention, but it allows people to solve for the same answer to mathematics problems regardless of where they are in the world. I just heard somebody today was saying, well, I'm in the Philippines. They never taught that. The origins of the convention can be traced back to earliest books on algebra back in the 16th century. It even goes way, way back beyond that. So, really trying to use, region or country as an excuse is not relevant. And many people believe that the order of operations is random and completely arbitrary, and it's really due to a lack of a fundamental understanding of the relationship between multiplication, division, addition, and subtraction. You've got PEMDAS, BODMAS, BEDMAS, BIDMAS. These are all just nothing more than six-letter acronyms that people use as memorization tools, but they all mean the same thing. There's no difference. First, I'm going to say that PEMDAS and BODMAS and the order of operations is not incorrect. They're correct, but what's wrong is the understanding that a lot of people have with these. Um, and take, for example, PEMDAS. With PEMDAS, multiplication and division, they have equal precedence. It's M and D, whichever one comes first, left to right. It would be better if we wrote it vertically like this, where you've got M and D on the same level, the addition and subtraction on the same level. I've even heard the acronym PEDMAS used before, PEDMAS. And honestly, it doesn't matter. The D and the M and the order of the S and the A don't matter because multiplication and division have equal precedence, and subtraction and addition also have equal precedence. It's one of the mistakes that people make. First of all, division is simply multiplying by a reciprocal. That's why multiplication and division have equal precedence. 10 fifths equals 2, or 10 multiplied by 1/5 equals 2. It doesn't matter. They're the same operation. And remember, there's an associative property which applies to addition but not subtraction. 6 plus 2 is 8. 2 plus 6 equals 8. But again, 6 minus 2 is 4. But 2 minus 6 equals negative 4. It's not the same thing. You can't just swap these numbers around like that. Now, 6 minus 2 is 4. Minus 2 plus 6 is also equal to 4. But notice what happened in this example. The negative sign went from the 2 to the 6. You can't do that and get the same answer. And I see people do that all the time, especially people who somehow believe addition comes before subtraction. I'll see them move these signs around thinking that it's equivalent, and it's not. Remember, subtraction is just the addition of a negative number. That's why addition and subtraction also have equal precedence. 6 minus 2 is 4. 6 plus minus 2 is 4. Multiplication is just shorthand for addition. 5 times 4 is the same thing as 4 added 5 times, which gives you 20. 4 times 5 is also the same thing as adding 4 5 times. Or, the other way around. Like, I mean, you could add yeah, which is easier to write? These are really the same thing. 5 times 4 is actually better written 5 added 4 times. 4 times 5 would be better written 4 added 5 times. But these are all still equivalent. It doesn't matter. 5 times 4 and 4 times 5. But again, multiplication, the basic thing to understand here is that multiplication is shorthand for addition. You have an associative property for multiplication as well. It doesn't matter the order that you multiply things. 3 times 2 times 5 is 30. 5 times 2 times 3 is 30. 2 times 3 times 5 is 30. It's all the same thing. But it does not apply to division. 10 divided by 5 is 2. 5 divided by 10 is a half. So that's not the same. So you need to understand these operations. The order of operations is not some kind of arbitrary thing that somebody just made up. It's true that it's a convention. It's not a law. It's not a rule, but it doesn't make it arbitrary and doesn't mean that you can just ignore it. And many people, unfortunately, have a poor understanding of what a convention means. It means that people have come together and agreed on a set of standards. They've agreed that parentheses or brackets can be used to alter the order of operations. Like you could make um, addition have a higher priority than multiplication if you put parentheses or brackets around that addition. They could have used anything. They could have used any symbol for that, but they agreed on parentheses and brackets for that. Order of operations is nearly universally accepted. It actually is a universal thing. The only thing there's a notable exception, I believe, in Kenya, where students were taught to solve division before multiplication. Now, again, not multiplication before division, but division before multiplication. But if you really understand how multiplication and division work, you'll find out that you'll get the same answer from the order of operations that most people are familiar with, or from the variant used in Kenya. You're going to get the same answer whether you treat multiplication and division with equal precedence left to right, or whether you consider division to have precedence over multiplication. It doesn't work the other way. If you try to say multiplication is always before division, you're going to get the wrong answer, and you can try it yourself. Some assume that the order of operations can be ignored since it's a convention and not a law or a rule. That's incorrect. It's an agreed upon standard that's been in every mathematics textbook that covers the topic printed in the last century, and even beyond that. It goes back, there's books from the 1600s, 1500s. What is the order of operations convention, after all? Well, there's 4 steps to it. It's parentheses or brackets. Depends on, a lot of it has to do with where you're from, whether you're familiar with using the term parentheses or brackets. Uh, Exponents, which are orders, also sometimes referred to as indices. This also includes square roots and factorials. Again, anything that is shorthand for repeated multiplication. Step number 3 is your multiplication and division left to right. And then finally, addition and subtraction left to right or not. Some remember it by these acronyms, PEMDAS, BODMAS, BEDMAS, or BIDMAS. Again, these all represent the same 4 steps. Some learned by a mnemonic. Please excuse my dear Aunt Sally. Still, it's only 4 steps. Order of operations is logical and it's far from arbitrary. I've already used this word arbitrary quite a bit already in this video. Multiplication is repeated addition. Division is multiplication by a reciprocal. Exponents are just a way of writing repeated multiplication. And then parentheses or brackets, they're just grouping symbols, and the items inside of them have to be solved uh, according to the order of operations. Like, anything inside of parentheses you look at first. And then you go, okay, are there any exponents inside of those parentheses? Do we have multiplication inside of those parentheses? And so on. They prioritize things within them. A number line would be arbitrary. I could have easily just displayed a positive numbers to the left of 0 instead of to the right. Most people are familiar with a number line from grade school or primary school, elementary school, where you start at 0 and your positive numbers go to the right, 1, 2, 3, 4, 5, and so on. Well, you could have just as easily arbitrarily have said, well, I want my positive numbers to go to the left, and I want the negative ones to go to the right. But it's an agreed upon convention. This is more arbitrary than the order of operations. This is just an arbitrary thing. Now, if you think that the order of operations is uh, is arbitrary still at this point, then you've really ignored the description that I've just gone through. Um, and really, I just gave the relationship here between multiplication, division, addition, and subtraction. So, don't make, another thing too, I'll say, don't make the mistake of posting a link in the comments to some video about the ambiguities in some problems or the hatred of PEMDAS and BODMAS, etc. I don't personally like PEMDAS or BODMAS either because I constantly see people making mistakes with them, not understanding them. They think that they're magical 6-step checklists. People think that PEMDAS and BODMAS give you different answers because one is telling me M before D and the other one's telling me D before M. I mean, that's the reason I don't like them, is because a lot of people don't understand them. There are ambiguities out there. There's ambiguities with things like implicit multiplication that people will argue about. Um, and there's a lot of problems with people misunderstanding these acronyms, but it doesn't negate the order of operations. So if you're posting a link like that, it basically is meaning that you don't really understand what you're posting. Now, I made a couple of videos about the problems of PEMDAS already. They're in the playlist. And those issues have nothing to do with trashing the order of operations convention. So listen, again, it's never been left to right with mixed operations ever. 3 plus 3 times 3 plus 3. Some people will solve this and they'll add the two threes together and then they'll multiply by 3 and they'll get 6 times 3, which gives them 18. Then they add 3 and get 21. And that's never been correct, ever. It's multiplication first. 3 plus 3 times 3 plus 3. You can take the multiplication out and replace it with equivalent addition, and the answer is 15. And the other thing to keep in mind is it doesn't matter where the multiplication is. It could be in the middle, it could be in the front, it could be here at the end. These three equations are all the same. They all equal 15. And why is that? It's because multiplication has priority. It always has. So many of the puzzles that end up on Facebook that you'll see people arguing over, they'll usually have like some kind of gotcha, such as a lack of parentheses, etc., that put some people into a fit. And unfortunately, they simply don't remember how the order of operations works after many years of being out of school. But it's not in people's nature to admit that they don't remember what they were taught. And there's a rampant myth out there that some people think if there are no parentheses, you just blindly solve left to right and ignore the order of operations. And that's so far from the truth. Ancient civilizations, including Egyptians and the Babylonians, they had some pretty accurate approximations for pi that they used in practical applications. And if you're not familiar with pi, you might want to look that one up. But you can see for the formula for the area of a circle that you do not multiply pi by the radius and then square the result. Even the formula for the area of a circle utilizes the order of operations. How is that? Well, a equals pi r squared, which is the same thing as r squared multiplied by pi. You square the radius before you multiply by pi. And why is that? Well, we just went through the whole order of operations, if you listen so far. And remember, exponents, r squared, you have the exponent of 2. Exponents are solved before multiplication. So yes, you square the radius. But notice how the formula is normally written. It's normally written a equals pi r squared, and you're supposed to know that the exponents are solved first. So right there you have it. A equals pi r squared. A equals pi r squared, which is the same thing as pi times r. This is equivalent. But it's a lot easier to write exponents. If this was r to the 30th power, you would definitely want to write r to the 30th power and not have r going out 30 times, right? Pretty simple. Here's an example that I see a lot of times on Facebook. 50 plus 10 times 0 plus 7 plus 2 equals what? Again, you solve the multiplication first. 50 plus 0 plus 7 plus 2 equals 59. Common wrong answers here are 9 or 69. Believe it or not, some people think that multiplying 10 times 0 is equal to 10, which is really sad, and it means that those people do not understand what multiplication by 0 is. It's not 9, and it's not 69. Another example, 5 plus 5 times 5 plus 5 equals what? Again, the multiplication's first. It's 5 plus 25 plus 5 equals 35. The answer is not 55. Again, another common example, 2 times 1 plus 6 times 6. Again, multiplication's first. 2 times 1 is 2. 6 times 6 is 36. Then you add 2 plus 36 is 38. The answer is not 48. Another one, 4 times 3 plus 5 times 2 plus 9 times 6. Again, multiplication first. You get 12 plus 10 plus 54. It adds up to 76. So the fallacy of this left to right method that a lot of people want to stick to and say that that's how it was done back in their day, it's really exposed when we try to legitimately rearrange the multiplication in the problem. You'll get different answers trying to blindly solve left to right. You take this example here, you got 5 times 2 plus 4 times 3 plus 9 times 6. It's 76. Now you can rearrange that multiplication and still get the same answer. But as soon as you change the problem and discuss these using money, sometimes it triggers a remembrance inside of people's minds about the order of operations. For example, I bought 4 Diet Cokes for $3 a piece, 5 iced teas for $2 a piece, and 9 cheeseburgers for $6 a piece. How much money did I spend? Well, you can represent that by this equation: 4 times 3 plus 5 times 2 plus 9 times 6. It's 12 plus 10 plus 54 equals 76. Really simple. It's 4 Diet Cokes times $3, 5 iced teas times $2, 9 cheeseburgers times 6. You spent $76, and I feel really bad for the poor souls who do not remember the order of operations because they just left the restaurant after paying $258. All right? So luckily there's cash registers and there's people that work them that understand how mathematics works, because the answer is 76. It's not 258. Um, you can't get the same answer when you blindly solve left to right if you rearrange the multiplication as I just did with the order of operations. And ask yourself, what competent mathematics teacher would have ever taught that nonsense? The truth is, they never did. It's perfectly valid to move the multiplication as I just did and get the answer of 76 over and over. And you could use a shopping example here. It doesn't matter what order I might buy the Cokes, the iced teas, or the cheeseburgers. You're going to spend the same amount of money provided you buy the same quantities and the prices didn't change. And there's multiple people that will try to convince you that back in the 50s, the 1960s, or 70s, they had teachers that made you think you spend more money if you bought the burgers on Monday and the Cokes on Tuesday and the iced teas on Wednesday than if you bought the teas on Monday and the Cokes and burgers on Tuesday. And unfortunately, a lot of these people, they don't see the fallacy of their own argument. And they're also throwing their teachers under the bus and making them look incompetent. And they don't even realize they're doing that. Believe me, I'm sticking up for those teachers back then. Those teachers knew what they were teaching. Unfortunately, the students weren't listening. And today, they're making excuses. And it also needs to be remembered that there are not multiple methods of education around the world regarding the order of operations. It's very common to see somebody in a forum state, well, back in my day, the answer was whatever. When I went to school, the answer would have been blah. Before all this new math, the answer would have been X. The answer is X using the old school math that I learned. I see these excuses all the time. And my best guess for these arguments, I don't know, these statements in the many forum threads where people always congregate and then they pat each other on the back for their false memories. The only explanation I have is the Mandela effect. And if you're not familiar with the Mandela effect, you might want to look that one up too. Because I see many people chime in on these threads and they'll say things like, yeah, I learned the same way as you did. I went to school back in the 50s just like you, or 60s or 70s. Pick your decade that you want to make that excuse. I've seen people say things like, well, I went to school in the 1990s. Oh my goodness, that's not that long ago. Or people will say, well, I graduated in 2015 and you solved left to right. I can kind of get it when somebody says they went to school in the 30s or 40s. That was a long time ago. So you have a little bit of an excuse for forgetting things if you haven't used a lot of math. But man, some of the recent ones are really kind of scary. Um, and I can always count on people. I still see it all the time. I can count on people that leave comments about the video or comments elsewhere saying, oh, well, I'm just talking about Common Core or the new math. That's a common excuse too, because these people have forgotten what they were taught. The order of operations is not new math and it's not Common Core. People who claim it's Common Core really have no idea what Common Core even means, in mathematics. Common Core is just a set of standards that don't change the answer of a mathematics problem. It's a different way of teaching, and you may or may not agree with that different way of teaching, but it doesn't change the answers here. The answers have always been what they are. I've had an ongoing challenge to offer money to anyone who can produce their mythological textbook that they claim taught them differently. I see a lot of people say, back in my day, it was all left to right. And I've always challenged those people, show me your textbook that said that. And a lot of these people that make these old school comments, they really don't bother to read or look anything up, so they miss out on the chance to make money on this bet. And honestly, I think, it really comes down to that. There's a certain uh, segment of people who really just don't ever want to be convinced. They are stuck in making excuses, and honestly, these videos really probably fall flat with them. They're not going to listen, but I'm putting it out there. Just this is the ammunition. So if you run into people and you're having a discussion about the order of operations, hopefully this helps you somewhat. If you got anything out of this video at all, please consider liking, sharing, subscribing, and I look forward to seeing you in the next video.